Section 9.3, polar and rectangular coordinates. The main goal today is converting between polar and rectangular coordinates. Now, rectangular, those are something we've worked with, for ages in Algebra 1, Algebra 2, pre-calc even, geometry definitely. Polar, we're just getting into polar here in Chapter 9. So we're going to convert back and forth between polar and rectangular. So if I give you polar, r comma theta, and I want you to convert it to rectangular, here's how you're going to do it. The x-coordinate of your point is going to be equal to r times the cosine of your angle, and the y value of your coordinate is going to be equal to r times the sine of your angle. And that's all there is to it. So when I give you the directions here, find the rectangular coordinate of each point. If we start with 5 comma pi over 3, and do this in purple, we can say, x is equal to our r value, and this is theta, so we can say 5 times the cosine of pi over 3, and we know the cosine of pi over 3, that is equal to 1/2, and 5 times a half, well, that's pretty darn easy. That's 5 and not 5 over 5, 5 over 2, 5 halves. If you wanted to, you could make that 2.5, up to you. For the y value, we're going to do the same thing. It's going to be 5 times the sine of our angle, pi over 3. The sine of pi over 3 is square root of 3 over 2. So we'll take 5 times the square root of 3 over 2. And really, there's nothing here we can do other than, if we wanted to make this 5 square root of 3 over 2, that'd be about it. This is, like I said, this one up here is 2.5. If you want to estimate or round, this one would be about 4.33. Up to you. So if we're being asked to write it in rectangular form, or the rectangular coordinates, this is going to be, we could say 2.5 comma 4.33. And that's really all there is to it. Let's try another one here. Number 2, negative 13, negative 70 degrees. Okay, so we're going to start with x. X equals our r value. This is r. This is theta. We can say negative 13 times the cosine of negative 70. And we need to be in degrees here. Just make sure your calculator is in degrees. And really, you can do this, just type this in your calculator exactly how you see it. Again, making sure you're in degrees. And what you're going to find that this is approximately negative 4.45. Okay? And then for the y value, y is equal to our r value again, negative 13 times the sine of our angle, negative 70. Once again, staying in degrees. And that's going to be approximately 12.22. 12.22. Okay, so really we just need to write our ordered pair then. So this was polar. Now we're writing it in rectangular form, so it's going to be negative 4.45 comma 12.22. If I asked you to go the other direction from rectangular, so we're going to start with x comma y, and I want you to turn it into polar, as in r comma theta, we just have a couple of steps to do for this one as well. So I'm going to write this in red. So our r value is going to be equal to the square root of x squared plus y squared. Okay. The theta, that's a little different. Theta is equal to the book. If you look in the book, it says arctan, but remember, arctan is the same thing as the tangent inverse of y over x. Tangent inverse of y over x. If your x value is less than 0, so if your angle is in the second or third quadrant, what you need to do here is you need to add pi to this. Okay, and this is when x is less than 0. Might be a good idea to write that in a different color or underline it or highlight it or something to make it stand out. If our x value is positive, so we're either in quadrant 1 or quadrant 4, we just need to do the tangent inverse of y over x. If our x is negative, meaning quadrant 2 or quadrant 3, then we need to add pi to our answer. Okay, just keep that in mind as we go. The reason we need to add this pi to it, if this was negative, if x was negative, we'd be taking the tangent inverse of potentially something negative. And remember, tangent, the principal values, going back a couple of sections back into chapter 7, the principal values are in quadrant 1 and quadrant 4, but if x is less than 0, that means we're in quadrant 2 or quadrant 3. So that's why we have to add the pi. Okay, so just keep that in mind. If your x is less than 0, we need to add pi to the end of our angle at the very end. So let's try a couple of examples here. Find the polar coordinates of the point. So we've got a point, -8, -12. So let's find our r value first. So r is equal to, we're going to take the square root of -8 squared plus -12 squared, and make sure your numbers are in parentheses when you do this in the calculator. If you want to do this, just type it in and get a rounded estimate. I'm okay with that. Let's go to 2 decimal places. If you want to make this a little more exact, feel free as well. If you go exact, this is going to be equal to the square root of 208. I'm okay with a rounded number. It's approximately 14.42. So the r value, pretty straightforward. So this is equal to 14.42 comma something. We'll figure out the something here. So the angle is equal to tangent inverse of, let's see, it's y over x. So we're going to do -12 over -8. -12 over -8 is a positive 3 over 2. If you wanted to do that in your calculator, tangent inverse of 3 over 2. Again, if you want to just type it in like this, feel free. If you want to type it in like this, either one's going to be fine. What you're going to find out is that this is equal to 0.98. But remember, this was the x value was less than 0, so we're in quadrant in this case we're in quadrant 3. Negative is quadrant 3, so we do need to add pi to this. So I'm going to say plus 3.14. And when we do that, what we're going to get is an angle of approximately 4.12. Now, if we're adding pi, we are no longer in, we can assume that we are not in degrees. We are in radians. This is a radian measure, 4.12 radians. Okay, so we can make this 14.42 comma 4.12 radians. Now, if you wanted to convert that to degrees, you could, but I would say that's just a little extra work that we don't necessarily need to do. If it's in radians, let's just leave it in radians. So we know if this does not have a degree symbol, that this is definitely a radian. Plus, just kind of thinking about, -8, -12, that's in quadrant 3. That'd have to be, if we're thinking in terms of degrees, between 180 and 270, and this clearly is not. Okay, so this definitely has to be in radians. So 14.42, 4.12 is the polar coordinate of -8, -12. Let's try a second one here. This will be the last one in the video. We've got 2, -4. So let's start with our r value. R is equal to square root of our x value, 2 squared, plus our y value, -4 squared. Let's see, 2 squared is 4, -4 squared is 16, so this becomes the square root of 20. If you want to make this exact, that would be 2 square root of 5. If you want to round it, I really don't care. That would be totally acceptable. We'll go 2 decimal places, so 4.47. That's just something in the calculator if you want to type that in. We need to find our theta now, so we'll just go x is equal to tangent inverse of our y over our x. So our y value is -4, our x value is 2. If you want to type this in the calculator as tangent inverse of -2, you can. Don't necessarily have to. Either way, you are going to get a number that is -1.1. Sorry, -1.11. Okay, and again, this is in radians, so if we're going negative radians, that's into quadrant 4, thinking about the circle, the polar coordinates, we're going that direction, 1.11 radians. Makes perfect sense because 2, -4, think about 2, -4 is in quadrant 4 as well. So, we're right on track with where we're supposed to be, so we can say our answer here, the polar form of 2, -4 would be 4.47, comma, -1.11, and that again is in radians.